Hi students, so this is our last week in our Earth module. So next week we're going to be taking our module test. And remember, we're only going to have one try on that. So it's going to be really important that you guys use your study guide. The other science teachers and I have taken the guided notes from each week and gone through and picked out the ones that are going to relate to questions on the test. So when you get your study guide from your instructor, it's going to be important that you guys use that and you use it on the test so you can be successful. Which leads me to this week, which is heat transfer. Please make sure that you're taking your guided notes. So again, you can use those on the study guide for the quiz next week. I'm sorry, the module exam next week and the quiz this week. So we're going to look at a couple different things. Let's first look at temperature. So temperature is the average kinetic energy of an object's particles. If you guys remember from our force and energy unit, that kinetic energy is the energy of movement. So when an object's particles move, if they move more rapidly, they're going to have more kinetic energy and more temperature. If they move slower, they're going to have less kinetic energy and a lower temperature. So also, when objects have more kinetic energy, they're going to have a higher temperature. And heat is the transfer of that thermal energy from one object to another. So we learned a little bit about thermal energy in the force and motion. And thermal energy is what warms the planet, it creates weather, it keeps up food, it keeps you warm on a cold day. So heat just doesn't appear out of thin air. Heat needs to be transferred from one object to another through that average kinetic energy or through that temperature. So there are three main types of heat energy transfer or thermal energy transfer. So what I want you guys to do is to go ahead and watch this movie, and it's going to give you a breakdown of conduction, convection, and radiation. But I'm going to take a pause and I'm going to show you different ways to look at conduction, convection, and radiation. So I wanted to give you guys a different look at conduction, convection, and radiation that's not the same as your video because you're already going to be able to view that video. So I wanted to give you guys a little something extra over here. So in this picture, we are able to see the three different types of heat transfer all at once. It's conduction when the person is touching the hot pan, there's convection within the boiling water, and then there is radiation from the oven, so stovetop, towards the pan. All right, so let's look at the definitions of these three. First up, we have conduction, and this is the movement of heat or electricity through matter. And solids are good conductors, particularly metals. Convection. This is the transfer of thermal energy through a liquid or a gas, sometimes called a fluid. So as you guys can see here, the hot or the red rises and the cold or the blue sinks. This is due to density differences. So the more kinetic energy an object has, the less dense it is. And the less kinetic energy an object has, the more dense it is. Hot fluids rise while cold fluids will sink. And remember, a fluid refers to a gas or a liquid. The last one we have is radiation. This is when energy is transmitted in waves or a stream of particles, and it's able to travel through space and other types of matter. So let's look at some examples of conduction. Touching a metal spoon in a cup of a hot liquid. If you guys have ever done this with hot chocolate, that spoon may be hot to the touch. if you put a heating pad on your back, you're going to be able to feel that direct heat. And then feeling the heat from a hot poker in a fireplace. You guys may not have seen pokers, but people who made real fires with wood, not with the gas or the electricity, sometimes they would need a poker in order to move the wood around and redistribute the surface area to burn the fire more effectively. So if you ever left that poker in the fire, it would be a conductor. And if you touched it, you would feel the heat, and it's not so much fun. Another example here is placing your hand on top of a basket of hot rolls. So if you guys have ever gone to a restaurant and those rolls come out and they're steaming hot out of the oven, if you guys touch them too quickly, you might burn yourself. The best thing to remember with conduction is it has to do with direct contact. So it's almost like an applied force where if there isn't contact, it's not going to be conduction. So when you guys are going through the quiz and you're looking to see if something is conduction, if there is any type of touching, just assume that it's going to be conduction. So let's look at some examples of convection, which is going to be hot rising and cold sinking. So macaroni rising and falling in a pot of boiling water. If you guys have ever done this, you can kind of see your noodles go in a circular motion if that water's really boiling. If you guys have lava lamps, they will sink and rise based on the densities of the lava inside the lamp. Hot magma rising in the mantle and cold sinking. So if you guys ever have seen inside the earth or diagrams, convection takes place within the Earth's mantle. Also, hot air rising in the atmosphere and cold air sinking. This motion is also what keeps hot air balloons afloat. And also hot water rising in the oceans and cold sinking. If we were in the brick and mortar setting during this unit, you guys would learn about the different ocean currents. When we get to ocean currents next module, we're only going to learn about surface currents. But what we have is we have those warmer surface currents, and then they get up to the North Pole or the poles, and they become cooler and more dense and they sink. So that's another way that convection occurs in our oceans. The easiest thing I can tell you to remember with convection, in order to say if it's convection, conduction, or radiation, is convection is always going to have hot rising and cold sinking with a gas or a liquid. Our last example is going to be radiation. So let's look at these. And it's going to be waves or particles of energy. So laying out in the sun at a beach, if you guys get a sunburn, the reason you get a sunburn is because of the radiation from the sun's rays. If you guys hold your hand over a match without touching it, you're going to feel the radiation or the waves of energy from that match. Now, if you go and you touch it, it turns into conduction. If you guys ever sit outside in a bonfire and you're feeling the warmth coming off of the bonfire, that is going to be radiation. But if you go and stick a marshmallow into the fire and char it, that is conduction because it's touching the flame. And finally, holding your hand over a light bulb and feeling that warmth is going to be radiation. When you're looking at identifying what is radiation, look for the word waves or particles of energy. Those are the key buzzwords that are going to help you identify the types of radiation in the quiz or on a module exam. The last thing that I want to talk to you guys about is probably the hardest part of the quiz. So in the quiz, it's going to ask you what's different about these three things: conduction, convection, and radiation. If anyone were to ever ask you what's the same, you can always say that they are all types of thermal energy or heat energy transfer. But this is going to ask you what's different. So if we look at conduction and convection, you guys can see in this photo that in order for conduction to happen, that person has to be touching the metal handle. So let's look at conduction and radiation. So that radiation is able to get to the pan through that empty space through particles. And then conduction, again, there is no empty space because there has to be touching. And finally, if you guys look at convection and radiation, the water molecules are going in a circular motion within the pan, but that radiation, again, is going through that empty space. So hopefully those little tidbits are going to help you successfully answer the 5th question on the quiz. When you get to the 4th slide on your lesson, you're going to be able to check your knowledge. It's going to be important for the quiz that you guys know the definitions for conduction, convection, and radiation, and then what they look like in different scenarios. So just like I gave you those scenarios a little bit ago and told you the differences between them, it's going to be important that you apply what you've learned here in this game. If you don't get the game right the first time, just go back and try it again until you're successful. When you guys get to the end of the lesson, I love it when you open up the Talk Like a Scientist and you check your vocabulary words to make sure that you have the right definitions and you have all of the definitions. It is my recommendation that you copy these into your guided notes just in case so you can be successful later on. This week, we're going to have a quiz. It's important that you guys wait for your instructor after you take the quiz the first time so we can help you improve on your second attempt and you guys can get a good grade. Have fun this week.